Dear students, firstly, I will introduce myself, Professor Ashik Chaubey, working as assistant professor in electrical engineering department of SND College of Engineering and Research Center, Viola. Now, in the last two lectures, we are seeing in high voltage engineering the breakdown in the solid dielectrics. Breakdown in the solid dielectrics. So we have seen the different mechanism in the case of direct mechanism in the case of solid breakdown, that is going to be the intrinsic breakdown, then electromechanical breakdown, breakdown due to tree and tracking, thermal breakdown, electrochemical breakdown. We have seen all this in the last lecture. What are the different breakdown mechanism in case of solids? That is going to be the intrinsic breakdown, electromechanical breakdown, breakdown due to tree and tracking, thermal breakdown, and electrochemical breakdown. Now, up till now, what we have seen the mechanism. Up till now, what we have seen only a single insulator, single dielectric, single dielectric, solid dielectric. Now, in this lecture, we will go for the composite dielectrics. We will see composite dielectrics. Now, you know that it is very difficult to complete the insulation system in an electrical equipment. We have the combination of dielectric materials. The insulation system having combination of more than one dielectric in series or parallel is called as a composite dielectric. It means the combination of more than two dielectric. They may be in series, they may be in parallel. They may be in liquid form, they may be in the solid form. So this combination of the dielectric either in series or in parallel is called as the composite dielectrics. See here, these different materials can be parallel with others, such as air or electric in parallel with solid insulator. It means just I have told you that it may be solid liquid, it may be solid gases, it may be gases liquid. So this is the combination that is going to be giving the more dielectric strength for that solid. So it is the breakdown in the composite dielectrics. Now, what are different properties of composite dielectric? The breakdown in composite dielectric generally consists of large number of layers arranged one over other. It means one layer, second layer, third layer, fourth layer, fifth layer. This breakdown in the composite generally consists of large number of the layers. This is called as the layered construction and is widely used in cables, capacitors, and transformers. Three properties of the composite dielectric which are important to their performance are given below. These three properties of the composite dielectric which are important to their performance are given below. First one, the effect of multi-layer. The effect of multi-layer, then the effect of layer thickness, and then the effect of interface. There are properties of composite dielectric. This one, effect of multi-layer, effect of layer thickness, and effect of the interface. So firstly, we will see what is the effect of multi-layer. The simplest composite dielectric consists of two layers of the same material. Two layers, one layer, second layer. Advantage is taken of fact that two thin sheets have a higher dielectric strength than a single sheet of same total thickness. Just I have told you starting. The composite solid having a higher dielectric strength as compared to the single dielectric. Because there is a layers that are put, one or two layers. So due to this putting of this layer, they have a higher dielectric strength than a single sheet of the same total thickness. The advantage is particularly significant in case of material having a wide variation in dielectric strength values measured at different points on the surface. That is the effect of multiple layers. It means in composite, I have told you that if you have to increase the dielectric strength, so you have to put up them in the layers form so that their dielectric strength is going to be increased as compared to single layer of same thickness. Now, second one, effect of layer thickness. Effect of layer thickness. Increase in layer thickness normally gives increased breakdown voltage. Just in the case of when we have seen solid electric addition, more thickness, more dielectric strength. We have seen when we have thermal mechanism or that breakdowns in there. But certain times, what happens? This thickness should be, if above that critical value, the thickness increases, then the breakdown occurs. So it is going to be, in short, I have to tell you that increase in layer thickness normally gives increased breakdown voltage. In a layered construction, breakdown channels occur at an interface only and not directly through another layer. Also, a discharge having penetrated one layer cannot enter the next layer until a part of interface also attains the potential which can produce electrical field state comparable to the other to that of discharge channel. It means that why in the layer construction this breakdown cannot occur at only interfaces, not directly through another layer. The interfaces, the interfaces. So this is going to be the effect of layer thickness. We know that increase in layer thickness normally increases breakdown voltage. So they directly does not attack on the layer. They are going to see the interface between the two layers. So this is the effect of the layer thickness. Now, effect of interfaces. The effect of interfaces. The interface between two dielectric surfaces in breakdown in composite dielectric system plays an important role in determining its what? Pre-breakdown and breakdown strength. Pre-breakdown and breakdown strength. Both are going to be determined. What are that? Pre-breakdown and breakdown strength. Discharges usually occur at interfaces and the magnitude of the discharge depends on the associated surface resistance and capacitance. Discharges usually occur at the interfaces and the magnitude of the discharge depends on the associated surface resistance and capacitance. When the surface conductivity increases, the discharge magnitude also increases, resulting in damage to the dielectric. But that when the surface conductivity increases, the discharge magnitude also increases, resulting in damage to the dielectric strength. Now, you know that as the dielectric losses are low, you know the term loss. This term loss is going to be, if the losses are less, it means it is going to be advantageous. So same thing is going to be here. If the dielectric losses are low, the cumulative heat produced will be low and thermal breakdown will not occur. It means if the dielectric losses are low, the cumulative, it means cumulative 2 plus 4 plus 5, 6 increasing, cumulative heat produced will be low and the thermal breakdown will not occur. However, several other factors can cause short and long-term breakdown, long-time breakdown. Several other factors can cause short and long-time breakdown. So in short, we will see what is the short-time breakdown and also we will see what is the long-time breakdown. Short-time breakdown. If the dielectric field stresses are very high, failure may occur in seconds or even faster without any substantial damage to the insulating surface prior to breakdown. If the electrical stresses are very high, failures may occur in seconds or even faster without any damage to the insulating surface. What in the short term? It means failure is very for the very long short time. That is going to be in this one. It has been observed that breakdown results from one or more discharges when the applied voltage is close to the observed breakdown value. It has been observed that breakdown results from one or more discharges when the applied voltage is close to the observed breakdown value. This exists a critical stage in the volume of dielectric at which discharge of given magnitude can enter the insulation from the surface and propagate rapidly into the volume to cause breakdown. That is a short. It means in the short duration that failure is for only short duration. It does not damage or it does not damage the insulating surface prior to breakdown. Prior to breakdown. It will happen only at the breakdown. This will not damage to the insulating surface prior to breakdown. This is a short-term breakdown. Now, long-term breakdown. Long-term breakdown, this is also called as the aging. It is also called as the aging. The principal effect responsible for the aging of the insulation, which eventually leads to breakdown, arises from the thermal processes and partial discharge. That the principal effect responsible for aging of the insulation, which eventually leads to breakdown, arises from the thermal processes and the partial discharge. Partial discharge normally occurs within the volume of the composite insulation system. In addition, the charge accumulation and the conduction on the surface of the insulation also contribute significantly toward the aging and the failure of the insulation. What does it say? Charge accumulation and the conduction on the surface, if they are going to be contribute significantly, and conduction on the surface insulation contributing toward the aging, then the failure of the insulation occurs at 100%. So this is going to be the short-term and the long-term insulation. Up till now, we have seen the composite dielectric or composite dielectric solids, and what is the definition, what is the different properties, that is going to be the effect of multi-layer, effect of layer thickness, effect of interfaces. Then we have also seen the breakdown mechanism in the composite material, just like the short-term mechanism and long-term mechanism. So in the next lecture, we will see the remaining portion. Thank you, everybody.